Well, hi, Core 4. I hope you've had a great Wednesday and you are ready to do some math. We are going to move forward with our exponents and we're going to start 8.2.2, which is power to a power today. So if you have not already downloaded the class slides from the module, please make sure you do that and keep that on one side and then make a split screen with this video on the other side. Hopefully you remembered your earbuds and you are set and ready to go to quietly do some learning as we move through this lesson together. When you're ready, I'll meet you on the next slide. We're going to start with a warm-up for our scientific notation. We have not done this in a while. I would recommend that you pause the video now and then come back once you have completed the warm-up. So assuming you're back after doing some completion yourself, I'm going to go through what you need to do. You are assuming that these are all written the way that the writer wanted them. The goal is to decide, are they correctly written in scientific notation or are they incorrectly written in scientific notation? The first one, the pink one, the answer would be no. This is not written correctly in scientific notation because the decimal point is not after the very first number, which would be 3. We are going to need to move that over. So it should be written as 3.534 times 10. Now we had to move this once. It was written as the third and it should be written as the fourth. So it is correct. 3.534 times 10 to the fourth. Moving on, the next one is correctly written in scientific notation. Yes. The decimal is indeed after the first non-zero number. There is a little x number, and then we have 10 to the power of 4. Our last one, this yellow or this green one, no, this is not written in scientific notation. We need to move this decimal so it's right there between the 7 and the 5. That's going to be rewritten as 7.5 times 10. Let me erase that. Times 10. Now it was to the power of 5. We've moved it back in the negative direction, so we're going to subtract 1. And that's going to be times 10 to the power of 4. So that is your little teeny tiny review of scientific notation. If you have questions on this, please pause the video, rewind it, go back, look at it, look at some of your work from school from last week. Otherwise, we are going to continue to move on. Do you remember the product rule? Way long ago in a time far, far away back last week. We're going to do a little warm-up. All right, starting out a little bit simple. Simplify. Remember, you keep the base and you add the exponents. So the base is x. You're going to add the exponents 2 plus 3. That's going to be x to the power of 5. All right, we have two bases here. We have a 5 and we have an x. So the 2 5s, it's going to be 5 to the power of 2 plus 1, because that's what these two are, right? And then you're going to have x to the power of 3 plus 1. That ends up being 5 to the power of 3, x to the power of 4. Please leave 5 to the power of 3 as 5 to the power of 3. You can write it out as 125 x to the power of 4, but that is certainly not expected or necessary. Questions? Let's make it a little more challenging. All right, so we've got a lot going on here. Let's take a look at what we have. I'm going to highlight a little bit so that we can see more clearly. We have an x here, we have an x here. Then we have y's, only one of them, and last but not least, we have some z's. Too hard to see with that color. So let's go back. My x's would end up being, I'm going to write it on the bottom, x. We had 2 and 3, that's 5. And then we have y, only one of them, y squared. And then our z is 2 plus 5, which is to the 7th. So we have y to the 5th, y to the 2nd, x to the 5th, y to the 2nd, z to the 7th. I'm a little distracted because I think my writing was really sloppy there. So, All right, moving on. Let's move on to the next one. Again, I'm going to do some highlighting so that we can see what we have. I have a base of 3. That's all I got there. I have a base of x. Again. I have a base of y and another base of y. And then I have a 5. Okay. I'm going to go back. I'm going to look at my numbers first. These are not like bases, therefore I'm not combining any exponents. I am simply multiplying. This is a multiplication statement. 3 times 5 is 15. My x is a single variable, single exponent, x to the third, and then my y would be to the second because I have 2 y's to the power of 1. Again, if you need to review this, please go back and do that. We're going to be learning a new rule today. You're going to be practicing that rule, and then tomorrow you're going to be putting all of this together. And it gets complicated real quick. So if you are ready, let's move forward. Power to a power. What is it all about? Let's take a look at what this means. What does this mean? This means 3 to the power of 2 raised to the power of 3. A power to a power. So that's what we're talking about. An exponent raised to an exponent. Remember that what separates these two exponents is a parenthesis. And what do parentheses mean in mathematics? They mean multiply. That is very important. If you remember back to our slides before, we had something like x to the third, x to the fourth. Is there anything in parentheses here? No. Because there's nothing in parentheses here, we add the exponents to get x to the 7th. This is totally different because we are separating the exponents, this is a lesson on exponents, with a parenthesis, which means the rule of parentheses will come into play here, which is to multiply. So hopefully you understand where that link is and where that logic is. It'll help you as you move forward. So let's get into the math. Okay. I would like you to use what we just talked about, and I would like you to try very hard to complete this table. I'm going to go ahead and complete it. You can pause this video and then come back and listen to the entire explanation, or you can keep it on and work with me as I'm doing this. Okay, so what does this mean? When we look at this very first one, I have 5 to the power of 2, so that's 5 to the power of 2. And then I have 5 groups of 5 to the power of 2. 1, 2, 3, 4, and 5 groups of that. All together in total, I have 10 5s. Okay? So let's try it again with this one right here. I have 2 to the power of 2, which is 2 times 2. You don't have to multiply, right? You do have to use that in there, otherwise you won't know. And then I'm multiplying that by 2 times 2. I have 4 groups of this total. So I'm going to write that out. 1, 2, 3, 4 groups of 2 to the power of 2. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 2 to the power of 8. Okay. So now I have 3 to the power of 7, and then I have 2 groups of that. So I have 3 sevens, yep. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 times, I'm going to put it down here because I won't have room. 1, 2, 3, 4, 5, 6, and 7. Okay. I have 2 groups of 3 to the power of 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 3 to the power of 14. Fabulous. All right. I have 3 groups of x and then 5 groups of those 3. So I have 1, 2, 3, and I'm going to do that 5 times. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. I need one more. 1, 2, and 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have x to the power of 15. Oof. Okay. Now this last one is where the challenge is. I have x to the power of 2 and y to the power of 2. So I have x, y, y, and I need 2 of those. So that's 1, x, y, y. Okay, so I have 1, 2, 3, 4 x's. 1, 2, 3, 4 y's. Whew, I'm exhausted from that. Okay, so there we go. Take a look at that, ponder that for a minute. When you're ready, I will meet you at the next slide. Okay, we're back. So, what does it look like? Well, what do you think this looks like? If I have 20 to the power of 3 raised to the power of 8, what would it look like? Hopefully your answer is 3 groups of 20, 8 times. That's an awful lot. I don't want to write that out. So is there a rule? Oh yeah, you betcha. There is a rule. What's happening? What's the rule? Well, can you guess what the rule is? Think for a second. What would be the rule? What are we doing? Let's see if we can figure it out together. Power to a power rule. The power to a power rule says the base stays the same. Remember, we always work with common bases. And the exponents are multiplied, just like I said. So, for example, x to the power of 5 raised to the power of 7 means x to the power of 5 times 7. That's what this parentheses means. It means multiply. That means it ends up being x to the 35th power. That should be what you figured out from the last slide, from all the stuff we just worked on. Let's put it into practice. Oh, right, of course. It's not that simple. It never is it? There's something called distributing, because why would it just be easy? When you have numbers in the parentheses and they're raised to a power, each number separately is raised. Each number is raised separately. That's what's important here, you guys. You need to make sure that you're doing a couple of things for me, that you're writing it out and you're not skipping steps. Because once we start combining stuff, if you don't get into a good habit, best practice, you're going to get lost. All right? Trust me, please. Let's get going. All right. Distributing using the power rule, the power to a power rule. What's happening here? We are taking this 3 right here, and we are distributing that 3 to the x, and we are also distributing it to the 2. So we end up with 2 separate exponential power rules. 2 to the power of 3 times x to the power of 3. 2 to the power of 3 is 2 to the 3rd times x to the 3rd. And in this case, I simplified it out to 8 because 2 to the power of 3 is easily known as 8. Do you have to go here? No, of course not. This is completely separate, or acceptable, rather. Let's try some more. Let's make it harder. All right. Power to a power. You can go ahead and try all of these if you would like. Pause the video. Come back when you're ready. Do one. Check it. Whatever you'd like. Or you can stay with me and we'll go through it one at a time. All right. The very first one. We are taking x to the power of 2 raised to the power of 5. There is a parentheses here, which means it's a power rule and it's multiplication. So what are we going to have? We're going to have x to the power of 10 because 2 times 5 is 10. That's basic. That's about as easy as it can get. Let's move on. I have 2, which is going to go to the y, and then it's going to go to the x. So what do I have? I have x to the power of 3 raised to the power of 2, and I have y to the power of 2. When I simplify that, I have x to the power of 6, y to the power of 2. That's my answer here, folks. Go back, take a look, see where your questions are. Come back and join me when you're ready. All right, next up, raising to the power of 3. For the y, for the 3, don't forget the 3. What do we end up with? 3 to the power of 3 and y to the 4th to the power of 3. I end up with 3 to the power of 3, y to the power of 12. You do not need to simplify 3 to the power of 3. You can if you'd like to, but you certainly do not have to. Up to you. All right, let's do another one. We have 4. It's going to go to the y, to the x, to the 5. Let's write it out. We're going to have 5 to the power of 4. We're going to have x raised up to the power of 4. We're going to have y to the power of 3 raised to the power of 4. When we're all said and done, we have 5 to the power of 4, x to the power of 4, y to the power of 12. What did you think? How did that go? Well, that remains to be seen, doesn't it? All right, so that's all that I have as far as teaching you goes. If you need to rewatch this, please feel free to. You can begin working on your power of a power, R and P. Please check the key. Please understand that this is due today. Tomorrow we're going to add one more little tiny rule, and then you are going to combine all 3 before we move on Monday to the last of 2 more exponent rules, and then we will spend a little more time combining those and seeing where we are at. Please behave yourself in class. Please make good choices. Remember, I am coming back, and I will see you soon.